An unprecedented astronomical event has begun. An object from another star system, known as 3I/Atlas, has passed Mars and is now racing at incredible speed toward the Sun. But something is terribly wrong. 3I/Atlas is releasing massive amounts of water and carbon dioxide, even at distances where it should be completely frozen. According to experts, this behavior defies every rule of comet physics. As it nears the Sun, the immense heat and pressure could cause it to explode or shatter into clouds of cosmic dust, taking with it the secrets of its true origin. Yet hidden within this danger lies a once-in-a-lifetime opportunity. If 3I/Atlas survives its journey into the inner solar system, humanity could witness, for the first time, a physical visitor from another world. This interstellar traveler may carry organic compounds, the seeds of life, that it has preserved while drifting through the vastness of space. So what exactly is approaching us? Is it a lifeless rock, a messenger carrying the origins of life across the stars, or something else entirely? It started as a faint glimmer in the deep sky. On July 1, 2025, the Atlas Telescope network in Chile detected something moving far too fast to belong to our solar system. At first, it looked like any other comet, just another icy traveler passing through space. But when astronomers traced its path, they realized the orbit didn't close. Instead of looping around the Sun, it stretched outward into infinity. That single calculation proved it came from somewhere far beyond, another star system entirely. NASA officially named it 3I/Atlas, marking it as the third interstellar object ever discovered, after Oumuamua in 2017 and 2I/Borisov in 2019. The number 3 meant it was only the third time humanity had caught a visitor from another world passing through our cosmic neighborhood. It was a reminder that our solar system is not isolated, that space is still alive with travelers carrying the stories of distant suns. Within days, telescopes across the world turned toward this mysterious object. Data came in from Caltech's Zwicky Transient Facility, the TESS satellite, and the James Webb Space Telescope. Each new observation deepened the mystery. Unlike most comets, 3I/Atlas showed a bright, dense coma but no visible tail. The ExoMars Trace Gas Orbiter captured an image showing a glowing sphere surrounded by haze, drifting like a silent ghost near the orbit of Mars. It was clear something about this object didn't follow the usual rules. The brightness of its coma suggested intense activity, but the missing tail confused scientists. Comets normally form tails when solar heat pushes dust and gas away. So why did this one shine so strongly without forming one? Some thought it might still be dormant. Others believed it was made of materials that reacted differently to sunlight. Whatever the cause, everyone agreed on one thing: this was no ordinary comet. As reports poured in, astronomers across NASA and ESA prepared for what could be the most important interstellar observation in decades. The question wasn't just where 3I/Atlas came from, it was what secrets it carried within. If its path through space was strange, its behavior soon became even stranger. What they found next would challenge everything we thought we knew about how comets live and die. By late October 2025, all eyes were on one event. After months of study, 3I/Atlas was finally about to reach perihelion, its closest approach to the Sun. For scientists, this was the moment that would decide everything. Would the interstellar comet hold together, revealing the secrets of its core, or would it crumble into dust before humanity could learn the truth? The tension across observatories on Earth was electric. Every telescope, from Hubble and Webb to ground-based instruments in Chile and Hawaii, was pointed at the same small patch of sky. Even the European Space Agency's spacecraft, orbiting beyond the Sun, was preparing to record what might be the most important comet event of the decade. As 3I/Atlas drew closer, its temperature began to rise sharply. The sunlight that had once barely touched it now struck with the force of billions of watts. Within hours, astronomers detected a rapid surge in brightness. The coma expanded, glowing brighter with each passing day, like a furnace waking from a long sleep. At first, it seemed to confirm the first scenario scientists had predicted, an explosive outburst triggered by intense heat. Spectral readings showed huge releases of carbon dioxide and water vapor, suggesting that the core was venting massive jets into space. For a few nights, the comet even became visible through small telescopes, a pale ghost racing across the inner solar system. But the excitement didn't last long. On October 29th, the day of perihelion, 3I/Atlas reached just 0.53 astronomical units from the Sun, about halfway between Earth and Mercury. At that distance, the solar radiation is almost 4 times stronger than what reaches our planet. Observers held their breath as the comet disappeared into the Sun's glare. For nearly 12 hours, it was completely invisible. When it finally reappeared, the news was mixed. Its brightness had dropped sharply, and the once perfect coma looked torn and uneven. Something had changed inside the nucleus. Many scientists believed the intense heat had fractured the core, causing parts of it to break away. Others argued that the comet might still be intact, but had lost most of its volatile gases. No one could say for sure. NASA and ESA teams began analyzing the data immediately. Early readings from JUICE and the Solar and Heliospheric Observatory, SOHO, suggested a complex event. Instead of a single explosion, 3I/Atlas seemed to have gone through several smaller bursts, releasing clouds of dust and ice in rapid succession. Each outburst lasted only minutes, but was powerful enough to alter its orbit slightly. If the object had been fragile before, the Sun's gravity and heat had likely pushed it to its limit. Some simulations predicted that smaller fragments might now be following behind, invisible to the naked eye but detectable by high-sensitivity instruments. If true, then what remained of the comet could soon scatter across space, carrying traces of its original structure far beyond our reach. Despite the uncertainty, the data collected during those hours was priceless. Astronomers could now compare the before and after of an interstellar object's journey past the Sun for the first time in history. By studying how its chemical composition changed, scientists would gain clues about how sunlight alters interstellar material, a process that cannot be reproduced in any laboratory on Earth. It was like watching a time capsule melt open, one that had drifted through the void for billions of years before revealing its story under our star's light. In the days that followed, telescopes worldwide continued to track the fading object. Its brightness stabilized slightly, suggesting that at least part of the nucleus had survived. If confirmed, 3I/Atlas would become the first interstellar comet to endure a close solar pass intact. But even if it had broken apart, its fragments would still offer scientists an unprecedented look at materials from beyond our solar system. Every grain of dust released by it was a message written in the chemistry of another world. For the public, it was a reminder of how fragile yet powerful cosmic forces can be. One frozen traveler from another star had crossed billions of miles, only to be consumed in hours by the sun's heat. Yet, in doing so, it had given humanity a glimpse into the wider universe, a chance to study something older than the Earth itself. It was both an ending and a beginning, proof that the cosmos is still sending us pieces of its story. But even after its fiery encounter, the journey of 3I/Atlas wasn't over. What it left behind, its dust, its gas, and its unanswered questions, would shape the next generation of interstellar research. So what happens now that humanity has witnessed the death, or perhaps the rebirth, of a traveler from another star? The more scientists studied 3I/Atlas, the stranger it became. Comets usually wake up only when they move close enough to the sun for ice to melt and release gas. But this one was already alive long before it should have been. Spectroscopic readings from ground observatories and the James Webb Space Telescope revealed something even more puzzling. The usual rule in our solar system is simple. Comets release more water than carbon dioxide when they warm up. But for 3I/Atlas, the pattern flipped. Instead of being water-driven, its main fuel seemed to be carbon dioxide, a volatile gas that reacts much earlier to sunlight. This meant that whatever materials built 3I/Atlas were not from a neighborhood like ours. They had to come from a colder and more distant system, one where carbon-based ice dominated over water. When scientists compared these findings to data from Oumuamua and 2I/Borisov, the difference was dramatic. Borisov behaved much like a typical comet from the outer solar system, while Oumuamua had shown no visible coma at all. But 3I/Atlas fell somewhere in between. It had a bright coma but no clear tail, a combination that made no physical sense. Its activity did not match its distance, its brightness did not match its mass, and its chemistry did not match any known origin. Every piece of data only deepened the mystery of what this traveler really was. As days passed, scientists began searching for explanations. One idea suggested that the surface of the comet might be rich in extremely volatile compounds such as carbon monoxide and carbon dioxide buried under a crust of frozen dust. When solar radiation reached it, the heat could have built up pressure underneath, cracking the surface open like a vent and allowing gases to escape. This would explain the strong jets of activity so far from the sun. Another theory proposed that the comet's nucleus was unusually porous. If sunlight could penetrate deeper than normal, it could trigger chemical reactions inside the core long before the outer layers even warmed up. Either way, something inside 3I/Atlas seemed unstable, as if it had been waiting for billions of years to release its hidden energy. Then came the light measurements. When astronomers analyzed how sunlight scattered off the coma, they discovered a polarization pattern that didn't fit any known model. The dust grains surrounding 3I/Atlas were reflecting light in a way that suggested they were chemically unique, possibly built from materials older than our sun itself. Some of these dust particles might even be interstellar fingerprints, carrying traces of the star system where the comet was born. If true, then studying this object could reveal how other planetary systems form, and perhaps how material travels between stars. The Keck Observatory added another twist. By splitting the light from the comet into its individual wavelengths, researchers found clear signs of nickel Ny and cyanide Cn, but almost no trace of iron Fe. This made no sense because metals like nickel and iron usually evaporate only at high temperatures. Yet 3I/Atlas was still too far and too cold for that to happen naturally. To explain this, scientists suggested that nickel atoms might be attached to complex organic molecules called PAHs, short for polycyclic aromatic hydrocarbons. When sunlight hit these molecules, it could break them apart, freeing nickel into space and producing the strange signals detected by Keck. It was an elegant idea and a haunting one, because PAHs are also the same molecules found in meteorites that have fallen to Earth. In other words, the building blocks of life might already be drifting between stars, hidden in the dust of interstellar comets. Every new image added another layer to the puzzle. Some showed jets of material rising unevenly from the surface, like bursts of steam escaping through cracks. Others revealed the faint beginnings of a tail that didn't point away from the sun as expected, but toward it. This anti-tail, as it was later called, was a rare phenomenon caused by heavy dust grains that refused to be blown away by solar wind. It proved that 3I/Atlas wasn't just active, it was breaking every rule in the book. Even the direction of its dust flow defied logic. All of this pointed to one conclusion: 3I/Atlas was not built under the same conditions as any comet born in our solar system. Its chemistry, its reactions to sunlight, and its dust composition all spoke of a completely different environment. It was likely formed in the outer reaches of a cold protoplanetary disk, around a star that might no longer exist. That made it not just a traveler, but a time capsule, a frozen relic carrying chemical memories from a place we may never reach. But despite all these discoveries, one question remained. If this comet had truly been asleep in the dark for billions of years, why did it suddenly awaken now? And what would happen when it faced the full power of the sun? The answers would come soon, because 3I/Atlas was racing toward its closest point to the sun. And as it approached that fiery moment, astronomers around the world prepared for whatever might come next. When the first month of observations came in, scientists finally had a full picture of 3I/Atlas in motion, and it was stranger than anyone imagined. Using a network of telescopes across the world, from South Africa's SALT to Spain's Nordic Optical Telescope, astronomers tracked the object's light every night between early and late July 2025. What they found was an interstellar traveler that looked calm on the outside but restless within. The comet spun once every 16.16 hours, a rhythm confirmed through precise photometry. Its light curve wasn't stable though, it flickered subtly, suggesting a lopsided shape or uneven surface activity. Over the course of the month, its brightness increased while the variation in light decreased, a clue that dust and gas were beginning to cloak the solid nucleus like a fog. This behavior meant that as 3I/Atlas drew closer to the sun, it wasn't breaking apart violently, it was waking up slowly. Color analysis revealed something even more mysterious. Its reflected light grew redder in the visible spectrum but turned blue beyond 0.8 microns, a wavelength behavior never seen in solar system comets. This shift indicated that its dust was evolving in real time, possibly changing in grain size or chemical composition as sunlight reached deeper layers. The reddening implied complex organic materials forming on the surface, while the later bluing hinted at fresher ice exposed beneath. It was as if the comet was shedding one face to reveal another. Unlike its predecessor 2I/Borisov, which erupted in visible jets and tails, 3I/Atlas remained eerily quiet. Images from multiple observatories showed no clear tail, only a compact, slightly asymmetric coma of dust surrounding the nucleus. The absence of fine particles suggested that the dust grains were unusually large, millimeter-sized, even pebble-like, too heavy for sunlight to push away. That explained why its tail never formed. The comet wasn't releasing the kind of lightweight dust typical of comets born near our sun. Instead, it seemed to carry the signature of a colder, older system where cosmic radiation had fused its surface into something dense and ancient. Estimates placed its dust loss rate between 0.3 and 4 kilograms per second, far below the violent ejections expected at that distance. This made it a weakly active comet by definition, quietly evaporating without dramatic outbursts. And yet, even in this stillness, it broke the rules, releasing water and CO2 far beyond the usual activation range, with a coma expanding thousands of kilometers wide. Everything about it pointed to an object that was fragile but deliberate, unpredictable yet oddly consistent. By late July, astronomers realized 3I/Atlas might represent a third category of interstellar visitor. Not inert like Oumuamua, not hyperactive like Borisov, but something balanced between the two, a slow-burning messenger evolving as it traveled through our light. It was rewriting how scientists defined activity itself, proving that silence in space can be just as revealing as an explosion of light. When it finally approached perihelion, the sun's full power would test every theory ever written about it, and perhaps expose what still lies hidden beneath that quiet glow. When NASA's Swift Observatory turned its ultraviolet sensors toward it, the data revealed something impossible. The comet was releasing 40 kilograms of water every second, even though it was still nearly 3 times farther from the sun than Earth. At that distance, ordinary ice should remain frozen solid. Yet this object was erupting like a geyser in the deep cold, defying every model of comet physics. It meant 3I/Atlas carried the same key ingredients for life, water and carbon, that once built planets and oceans in our own system. If comets like this drift between stars, it could mean that life's raw materials are spread across the galaxy, seeded by objects just like this one. In early September, astronomers noticed a strange green halo forming around its core. Normally, that glow is caused by dicarbon gas reacting to sunlight, but when scientists studied the spectra, the usual dicarbon signature was missing. Instead, they found faint traces of other unidentified molecules, something that fluoresced under ultraviolet light but didn't match any known cometary gas. Some researchers suggested it could be a brand new kind of organic compound, forged in the frozen dark of another star system. Others proposed that radiation from the sun might be transforming surface carbon into reactive gases, creating a color never seen on a comet before. Then, as if to test its limits, the sun itself struck back. A powerful coronal mass ejection erupted on September 24th and slammed straight into 3I/Atlas. Its brightness barely changed, its water output remained steady, and its coma thickened instead of breaking apart. To astronomers, that meant its surface was unusually cohesive, not the loose rubble typical of a comet, but a hardened shell possibly fused by cosmic radiation over millions of years of travel. Meanwhile, NASA's SphereX telescope began detecting carbon dioxide streaming from the coma, confirming that both CO2 and water were venting side by side. It showed that 3I/Atlas wasn't just active, it was alive in a chemical sense, releasing compounds from different depths of its surface at once. The alternating jets even caused its light to pulse in subtle cycles, almost as if the comet were breathing. Across observatories, scientists compared data and realized something profound. This was the first time a truly interstellar object had been caught in the act of evolving under solar heat. And now, as 3I/Atlas slipped behind the Sun for its October conjunction, every telescope on Earth fell silent. For the next few weeks, no one would see what was happening to it. No data, no signals, only waiting. What would it look like when it emerged again? Would it survive the heat, or come back changed beyond recognition? When the light from 3I/Atlas finally faded, scientists were left with more questions than answers. But even in its silence, the comet had changed everything. It was no longer just an icy object passing through our solar system, it had become a window into how the universe shares its history. The data gathered during its brief journey near the Sun opened an entirely new field of research: the science of interstellar exchange. For the first time, astronomers could compare materials from another star system with those formed around our own. The differences were striking, but that contrast was exactly what made the discovery so valuable. It proved that planetary systems across the galaxy might not be isolated islands, but parts of a vast web trading dust, ice, and the very ingredients of life. The significance of this goes far beyond one comet. With 3I/Atlas, researchers could test theories about how elements move from one star to another and how early planetary systems form. Some models now suggest that objects like it may have carried carbon compounds and water across light years, seeding other worlds with materials that could one day lead to life. It gave new weight to the idea that we might all share the same cosmic roots, built from the same ancient dust scattered across the galaxy billions of years ago. In that sense, 3I/Atlas wasn't just a traveler, it was a messenger, carrying proof that the story of life might be a shared one. The impact of this event also reached far into the future of exploration. Astronomers are already preparing new tools to catch the next visitor before it slips away. The Vera Rubin Observatory, set to begin full operation soon, will scan the entire night sky every few days, capable of spotting fast-moving interstellar bodies early in their approach. And in Europe, the Comet Interceptor mission, launching in 2029, is designed to wait in space, ready to chase the next object that crosses our solar system. It could be another 3I/Atlas, or something even stranger. This time, humanity will be ready not only to observe, but to meet such a traveler face to face. Every lesson learned from 3I/Atlas also helps scientists refine our understanding of our own beginnings. By studying what it carried, the carbon, the metals, the frozen gases, we gain insight into what our solar system might have looked like before Earth even formed. Each discovery is a reminder that our Sun, our planets, and perhaps even our DNA are built from the same material drifting across the stars. 3I/Atlas taught us that the universe is constantly recycling itself, trading the building blocks of creation across unimaginable distances. It showed that every comet, every rock, and every spark of ice might hold a piece of someone else's story. For a moment, as that interstellar object passed through our system, humanity was reminded of how connected we are to the wider cosmos. It proved that the universe is not silent. It speaks in chemistry, light, and dust if we know how to listen. But as the memory of 3I/Atlas fades into history, one question remains. What if the next object that crosses our sky is not just a messenger, but a sign that something or someone out there is watching back? In the end, 3I/Atlas has become more than just an interstellar comet. It is a reminder of how small and young our world truly is in the endless ocean of space. Whether it survives the sun's heat or breaks apart into dust, it has already changed the way we see the universe. Through this single visitor, we are witnessing the bridge between stars, the proof that matter and perhaps life itself can travel across galaxies. Every observation brings us closer to understanding where we came from and what else might be out there, waiting to be found. Because somewhere beyond our solar system, another object like 3I/Atlas might already be on its way, carrying another piece of the universe's grand story. Do you think 3I/Atlas is just a wandering comet, or could it be something far more intentional, something sent to remind us that we are not alone?